There are a bunch of index laws that we need to know, and these are three of them that I'm about to go through. With these first three, there's a couple more, these first three here, we have represented a generalisation here, or a general form for how these rules play out. So you can see here I've got a to the power of m times a to the power of n equals a to the power of m plus n. So this is a base number, which could be anything, could be 3, 5, whatever. And these here are a couple of different powers. If we multiply something with the same base, has to be the same, then we just add the powers together. That's the rule. So let me just show you why this works. If I had 2 to the power of 3 times 2 to the power of 2, I could write that out in long form. I could write this out as 2 times 2 times 2, and I could write this one here out as 2 times 2. They're being multiplied together. How many of them do I have? I have 5 of them there. So that's equal to 2 to the power of 5, which is 3 plus 2. Okay, just sort of showing how that rule works. So whenever you see them with the same base, must have the same base, doesn't matter what the powers on top are, you add those powers together. Sometimes the powers could be a letter instead of a number. And so if you had that, if you had 2 to the power of x times 2 to the power of y, there's not a lot we can do with x and y in terms of adding them together. We just have to write it as 2 to the power of x plus y, because that's what the rule says we have to do. Now the second rule here, a to the power of m over a to the power of n equals a, and a to the power of m take n. This bar here is the division bar. So really we're saying if we have one base to a power over the same base with a different power, or the same power, whatever, with a power, we have to take away the bottom base from the top base. And I'll show you why this works. We'll use the same numbers as before. So what if I have 2 to the power of 3? Let's change it. Let's make it 2 to the power of 4 over 2 to the power of 2 squared. Now if I write that in expanded form, I would have 2 times 2 times 2 times 2 on top, and I would have 2 times 2 on the bottom. Now you should know that if you have a division bar, and you've got a number being multiplied on the top and on the bottom, you can actually cancel them out. I can go, that's this, cancelling that out, and that, cancelling that out. So 2 times 2 is 4, which is the same as 2 squared. Okay? Which should be my answer. 2 to the power of 4 divided by 2 to the power of 2. 4 take 2 is 2. Okay? So it works out. Next up, before I go any further, another way to think of that is if I actually thought about what is 2 times 2 times 2 times 2, that is true for a 16 on top, divided by 4 equals 4, which is 2 squared. So it's just another way of thinking about it. Whatever you do, it's going to work out that you are subtracting that power from that power if these bases are the same. Here we go, a bit of a different one. We've got brackets here with a power outside and a power inside, and then the powers get squished together and brackets go away. What this is saying is if you have something, a power inside the bracket and one outside the bracket, you multiply them together to get the new power. So I'll show you why that works. So let's say if I had 2 to the power of 2 to the power of 3. Now if I wanted to write this in expanded form, that would be the same as, run a space here, 2 times 2, that's what 2 squared is, isn't it? And how many times is that being multiplied by itself? 3 times. Times 2 times 2 times, oopsies, 2 times 2, how many 2's do I have being multiplied together? 6, okay? So that is equal to 2 to the power of 6.